So, good morning. So, here I'm going to explain about bus and memory transfer, right? So, here to transfer the memory, so we require some bus runs. So, why here using means I want to transfer the data from one register to another registers, right? So for the purpose, we require the buses. That is the main purpose of the bus to transfer the data from one register to another register. Otherwise, one location to another location. Okay. So we require the bus lines. That means it can transfer the data from one location to another location. See, for example, I want to transfer the data. For example, I want to transfer the data from R1 to R3. Okay. So for this purpose, the data is there in R1 register. The data I want to transfer to the R3 register. Okay. So for that purpose, we require some bus lines. So like that, we know the different types of the registers also, right? So to transfer the data from one register to another register, for that purpose, also we can use the bus lines. So finally, we can say that to transfer the data from one location to another location, we require the bus. So here, simply I will explain so how to transfer the data from one register to another registers, right? So here, with using in this, we are using some multiplexers. With the help of the multiplexers, we can transfer the data from one register to another register, right? For example, I want to transfer the data from ABC or the some registers, right? So, for example, I want to transfer the data of this C to some R1 register. Okay. So now, what is the process means? First, we can keep the C data in the bus line, right? So after that, from bus 2, we can transfer the data to R1. Okay, so that means is nothing but we can transfer the data C to R1, right? So our final goal is I want to transfer the data from register C to R1 register C to R1. So now first part to do that, this register C data we have to keep into the bus line. We have to keep into the bus line. So after bus line 2, we can transfer the data from the R1. That is the process, right? So for this purpose, I am using the 4 multiplexer. So first we can take in this example, we are taking the 4 register, right? So each register, the capacity is the 4. So now I'm taking that 4 registers, right? See simply how to design this diagram is the register A, right? So 4-bit, the register capacity is the 4-bit. So 0, 1, 2, 3. So we can take as the A0, right? So A register. So next one is the A1, and next one is the A2, and next one is the A2. So like that, we're taking the 4 registers. So my next register is the B register, right? So it is the register B. And the register C, right? And the next fourth one is the register. 4 registers. Each register capacity is the 4-bit. So here, so again 0, 1, 2, 3. So we can get the values of the B0, B1, right? B2 and B3. Similarly, C0, C1, C2, C3. So similarly D0, D1, D2, D2. Okay, right? So in our example, I want to transfer the C register data to R1. So the R1 is there some outside. Okay, now this register data, I want to transfer into the some R1 register. So for that purpose, here I'm using the 4 multiplexers. So we are having the 4 registers. So that's why I'm taking the 4 multiplex. That is the 4 input. We can take the 4 input, right? So 4 by 1. That means it can take the 4 inputs and generate and send output back to the 1 output. So we are taking the 4 multiplexer. So it is 0th multiplexer. So 4. So A0, right? So B0, C0 and D0. That means this A0 register value will go here and B0 first bit value will go here. and the third register first bit value, fourth register first bit value. So like that, we are taking the 4 multiplexers, right? So it is the multiplexer, second multiplexer that we are taking the 1, and next it is the third multiplexer, and each multiplexers are the 4 only, 4 input only, and we can get the 4 by 1 multiplexer, 4 input and 1 output. See, right? This is 0. So here we're giving the A0, A1, B0, C0, D0. So here the value is the 1. So A1, B1, C1, and D1. So now here we can take as the A2, B2, C2, and D2, right? So here A3, B3, C3, D3. Okay, right? 4 inputs. That, for example, see this multiplexer, this D3 will come here, this C3 will come the C multiplexer, B3 will come the this B register, and A3 will come the A register. Okay, right? So we have to select the multiplexers. For that purpose, I'm taking the 2 selection lines, S1 and S1, right? So this S1 we can connect to the 4 multiplexers, and this S0 also connect to the 4 multiplexers. Right? So now we can connect like this. So now you simply can observe that 2 selection lines with selecting connecting to the all the 4 multiplexers. Right? Okay. So now in our example, I want to transfer the C register to R1, right? So 4 inputs. For example, what is the values of the C register? C0. So C0 means 0 multiplexer. C0 we can find. Okay. C1, first multiplexer, third bit. Okay, na? And C2, second multiplexer. Like C3, third multiplexer. That is the 4 inputs. So for example, see, that is our register C value. So for example, I want to connect to the D3, 4 input. That means this A3 will come from, A3 will come, okay, so come to here. Similarly for B3 will come to the here. C3 will come to the here, and D3 will come to the here, like that. So for each and every multiplexer, we can take the 4 inputs from the register, any one of the register. Okay, right? So now it can generate the 1 bit output. The output will come from the 4th multiplexer, and it is the 3rd multiplexer, and it is the 2nd multiplexer, and it is the 1st multiplexer. It is only the 4-bit output, right? Four-line common bus. Okay. See, for example, I want to transfer the C register. So now here, how the selection lines can help X1 and S0, right? So we can take the 2, so 4 possibilities, 0, 0, 0, 1, 1, 0, and 1, 1. Okay. So which register is selected? Okay. If it is 0, 0, then we can select the A register, right? If it is 0, 1, then we can select the B register, 1, 0 C register, 1, 1 D register. So now I want to transfer the C register to R1. So during that time, the selection line value is the 1, 0, right? So we can select the register C. Now the register C data can transfer to the 4 multiplexers. Okay, so 0, 1 means that is the 3rd bit, right? So in all the multiplexers, 3rd bit values will be selected. So now see, otherwise, so what is the register C value? C0. So first multiplexer 3rd bit, C1, second multiplexer 3rd bit, C2, third multiplexer 3rd bit, and C3, 4th multiplexer 3rd. Okay, now here we can get the C3 value, here C2, the output, here C1, and here the C. So now in our bus system, we are having C3, C2, C1, and C values. Okay, so that is nothing but C2 bus. Okay, so after that, we can transfer the bus to, okay, R1. So now, what is there in the bus? So in our bus, we are having these values. These values. Now, this will transfer to the R1 system, right? So that is the like that we can transfer the data from one register to another registers with using bus lines. So for that purpose, we are using the multiplexer. Okay, so maybe we can get some confusion how to give the this number. So here we have to remember that that is a register, right? So 4-bit A. So A0, A1, A2, A3. Similarly B. So B0, B1, B2. Like that we can give the numbers. So similarly here multiplexer. Multiplexer 0. 0 means all register 0 bits will be there in the first multiplexer. Multiplexer 1, right? So all registers, right? So second bit values will be there. And this one, that means this one. And multiplexer 3, that means in the register third bit values, right? So multiplexer 3 means register third bit values. So like that we can remember that for giving the names of the multiplexer A0, B0, C0 and D0, right? So like that we can transfer the data from one register to another registers with using bus lines. Okay, so otherwise we can transfer the data from one register to another registers with using multiplexers. Okay, so you can understand that how to design